Hi, subscribe to this channel. Go to this red subscribe and click. And you also see this bell shape. So click on this and select all. This means you would be getting notification of all videos uploaded on this channel. Cheers. What we are going to learn today is derivative of, and here we say e raised to the power x. Yeah.
Yeah.
Do you know this thing or no? Or should I do it? Yeah. I would be taking something different approach from the book. So I would go from a difficult to easier one. Instead, in the book, they have gone from the easier to difficult one. But I think it would be good if we start from the difficult one. Yeah.
Yeah.
So it
Yeah.
says if y is equal to e to the power of fx. Yeah.
Yeah.
And you have to take its derivative. So this is like this. Then, have you covered this topic in your school or not?
No.
Okay, that's good then. Then, then dy upon dx would be e fx into, so this dot means times, f
Yeah.
bar x. Do you understand this or
Yeah.
somewhat? Yeah.
Yeah.
Let's try to do it in a very simple way, and then let's do one example. Yeah. The
Yeah.
example says, let's E is equal to, and let me take another color. Let's say Y is equal to E raised to the power of 5x minus 2. Yeah.
Yeah.
And now we have to find dy upon dx. Can you try it yourself first? So we have to find dy upon dx. So let's compare it with this. So we do it together. So what should I write first?
Uh, E.
Yeah, E. So we are comparing it with, let me highlight it. Yeah, so we are comparing our question with this now. Yeah,
Yeah.
okay. So what should I write first? E raised to the power fx. What is fx in this question then?
Fx is 5x minus 2.
Good, that's good. So first we would write, what should I write?
So it should be e to the power of 5x minus 2.
Very nice. So it would remain the same, 5x minus 2. And then times. And what is the times now?
Times by 5. The derivative of
Yeah,
f of x.
yeah,
So,
yeah, it is then 5. Yeah. So the
yeah.
answer comes 5 e 5x minus 2. Yeah,
Yeah.
that's easy. That's easy. Let's look at something which we will come across. Therefore, let me take a red color now. Let's say if y is equal to e raised to the power x. Can you tell me then what is dy upon dx?
It's e to the, it's just ex. E to the power of x.
Yeah, why? Because in this case, fx is x and f bar x would be just 1. So we are actually multiplying this by 1 and then therefore uh, I hope it's clear.
Yeah.
Okay, let's do two questions more, which may be a little tricky, and then we would go to the exercise example. So now let's say your y is equal to e raised to the power x square plus x. Yeah, can you
Yeah.
solve this thing? So what would be dy upon this dx?
dy upon dx would be 2x plus 1.
2x plus 1, yeah.
Yeah, and then times by e to the power of x squared plus x.
Yeah, don't forget a bracket. That's very
Yeah,
important. E x square plus x. Yeah, so
yeah.
this is something. Okay, we do one more question and then we move to our exercise then. What if y is equal to x square into ex? So it's become a little tricky. So
Yeah.
what formula or what rule we should apply on this?
Uh,
We have to find dy upon dx. So
so
dy upon dx is to be found.
okay, so is dy upon dx x squared times e to the power of x?
Okay. The question was what formula we should apply first,
Oh,
the
formula.
approach.
So the formula would be e to the power of f of x times f bar of x.
But this is something different. If we look at this, it appears that it is the multiplication of two functions. X square is one function
Oh, yeah.
and ex is the second function. So what formula if you have? If you
Okay.
have you understood that?
Yeah, so the product
Yeah,
rule.
it's a product rule. So we will have to use the product rule. So that's important that we use the product rule. So now you let me know how to do that. So let's change the
Oh,
color. So dy upon dx is equal to what?
it's equal to x squared times e to the power of x
Yeah,
plus e to the power of x times 2x.
very nice, very nice. So this is, and we can then take ex common. So this becomes x square plus 2x. Is it?
Yeah,
Yeah.
yeah, yeah,
Or we can even simplify it even more. We can take even x common. If we take x common, it will become x e raised to the power of x plus 2. Got it?
yeah.
Okay. Before I come to the next question and solve it, but I would do it in another way with you. First, we would make it a simple. So this is another example. I take a red color for this. Let's say y is equal to e raised to the power x divided by x. So what would be the dy upon dx then? So what rule you would use for this?
Uh, I forgot what the rule's called. I forgot the rule. Yeah,
Okay, but you remember the
I
rule or you can look
yeah,
at, yeah.
yeah. I remember the rule.
Yeah, like if you see there, this is the product rule which you saw.
Yeah.
So what would be that thing? This is product means it was being timed. So what is this rule then? Or what is this
Uh,
operation?
I can't remember.
Okay, no worries. So let me know how to solve this then.
Okay, so you take so it becomes x times by e of x, e
Okay,
to the power of x.
okay,
Yeah. Minus e to the power of x divided by x squared.
yeah. So it's a division, divide rules. So yeah, like the
Yeah.
product rule, it was because then you take the derivative of first or the function in the numerator times by the function in the denominator minus the derivative of the function in the denominator times the function in the numerator divided by square of the function in the denominator. Yeah,
Yeah.
that's good. Yeah. Okay. So we move to something which is from this question now. So actually, if you plot y is equal to y is equal to ex upon, do you have so can you plot this in your calculator, scientific calculator?
Okay.
Yeah, kindly. Yeah.
Yeah.
Are you able to plot it?
Yes.
Okay.
Yes. Yeah.
Uh,
Sorry, my calculators.
Sorry?
Yeah. Yeah. Sorry, just give me one second.
Yeah. As you are able to do, kindly let me know.
Yeah. So yeah, I plotted it. Yeah.
So how does it look like? Just explain it in the words.
Oh. So uh, I don't know. So it goes along the x-axis. Uh, from the left side, it comes along the x-axis,
Okay, from
then
the
goes
left.
down.
Okay, so I mean, what you are saying, it's something like here, like this?
Uh, I think almost, yeah.
Yeah, good, good.
And
And
then at the and then on the top right corner,
yeah, that's called
yeah,
first quadrant. Yeah, it's
first
also called,
quadrant,
yeah, it's called
yeah,
first
first
quadrant.
quadrant. So around maybe like three on the y-axis, it curves the tiniest bit down and then goes up.
Okay, so it means it's going something like if I plot it, it goes like this. Yeah,
Yeah, but just a little bit to the left, yeah, but it's
okay,
good.
yeah, yeah, okay, that's good. So it means, so this is the graph of, now the question is, this is determine, it's actually it's with the, presently you can use the calculator. So what is local minima? Local minimum is the only stationary point. So it says, the question says, use calculus to prove, use calculus to prove the local minimum is the only stationary point, that the local, which one is the stationary point? It would be somewhere here where I have put a dot. Yeah,
Yeah.
local minimum, and you have to find this its value.
Okay. Yeah.
Minimum is the only stationary point. Yeah, do you understand?
Yeah.
And find its exact location. Exact location. Can you do this question?
Sure.
So how to do that?
Um. So you would take the derivative of ex over x,
Yeah,
and
we have already done. Yeah, yeah,
yeah,
good.
so then you'd make that equal to 0,
Yeah, good, good. So we have
and
dy
then
upon dx, which we did just earlier. This was something like which we have x ex minus ex upon x square. Yeah. So kindly put that and let me know what you come, what is the value which you come up with.
sure. Yeah, so I got x equals 1 from 0.
Okay, x is equal to 1.
Yeah,
It means you are talking about this value. This would be x is equal to 1.
yeah.
And what would be the value of y at this? So I
Um,
mean, I am asking for this place.
yeah. Okay. I'll put it back in and see.
Are you doing it with the calculator or you are doing it on a
With a
notebook?
calculator, yeah.
Okay, just do it and then we would also do it with the.
Uh, so on the y-axis, it's at point about 272,
Yeah, 272 means it's actually,
2.7.
yeah.
Yeah,
Just may note it down. We would do it because we would do it the other way by doing it on our notebook instead of calculator, and then we would see whether the answers are same or different. Yeah.
yeah,
So what you said was you will put dy upon dx is equal to 0. Yeah.
yeah,
Because for stationary point to find
yeah.
stationary point, stationary point. Yeah, we will put this dy upon dx is equal to 0. So it means we would put x ex minus ex over x square is equal to 0. Yeah.
Yeah.
So can you simplify this equation and find me what is x from here?
Uh,
What would be the next step?
would it be to uh can you times 0 by x squared?
Yeah, and what is yeah, good, good. Once what is if you time x square with 0, what is the answer?
0.
Yeah, good. So what, so this equation simplifies to what then? Good. You are in the right track. So that this equation simplifies to what? Mul Next wave as you
So then
multiply.
now it has x to the power of e.
X
So yeah, it's
ex
oh yeah, x e x
minus
minus e to the
ex
power of x.
is
Yeah,
equal to 0.
0. Yeah,
You got that? Because we have multiplied that.
yeah.
And can we solve it further from here?
Can you
So what should we do?
can you divide 0 by x?
No, we can't divide 0 by x because we see x is here, but it's not here.
Okay, yeah.
So what should we do?
Um,
We see something here, that here it is ex and here it is also e raised to the power of x. So what can we do? Can we take them common?
yes, yes.
Okay, so what would be if you take these common?
Uh, could you? I'm not sure. No.
Simple. Let me ask you another because I would like that you understand instead of just I doing it. If you have something like this, a times b minus b is equal to 0. Can you let me know how this equation simplifies or if we take something
Oh,
common?
yeah. You take the b out. That's common.
Yeah, b, then
Yeah. Then have the a minus 1 on inside.
a minus 1 inside a bracket. Yeah.
Yeah.
So it's the same thing here. You see, what is in that case of b? In if I compare this with this, what is b there?
B is e to the power of x.
Yeah. And what is a?
X.
So can you now help me to simplify this equation?
Yeah. So you factor it into e to the power of x
Yeah,
times by x on the in bracket x minus 1.
is equal to 0. Very nice. So this is, yeah. And if we see here, can we get rid of this e raised to the power of x now somehow?
Uh,
This
I'm not
is,
sure.
it's a simple algebra now, because if you have something like this, let me say this again. So I have a b times a minus 1. So if I have to get rid of b in algebra on the left
Yeah.
hand side, what you do then?
Divide by b.
Both sides. So it
Yeah,
will
both
become
sides.
a
Uh,
minus 1 is equal to
0.
0, because 0 divided by anything is 0. So let me know what is then here.
Yeah. So x equals 1.
So
Oh, yeah.
x
Sorry. Yeah.
minus 1 is equal to 0, and this
Yeah.
implies x is equal to 1.
Yeah.
And that's the same thing which you found from your calculator also. So this x minus 1 was actually we found from your calculator here. Let me highlight it. Yeah,
Yeah.
does it make sense?
Yeah.
Okay, and if it is x is equal to 1 and we have y, let me see what was y. So let me write y again. We had y is equal to e raised to the power x over x. This was our equation, yeah? I just put a box around it. So far, so good?
Yeah.
Okay. So if x is equal to 1, so what is y then?
So then y is equal to uh 2.7.
No, no, from this equation. We don't know
Oh,
because here I am referring to this thing. We had this. So then
yeah.
y is equal to,
Y is equal to e to the power of 1 divided by 1.
and that is equal to e.
Yeah.
E raised up. And what you were saying 2.71 is actually the value of e. You understand that?
Yeah.
So it was actually here, it is e. And this point is actually 1 comma e. And that's the minima in this.
Yeah.
Yeah? Does it make sense or no?
It does, yeah.
Okay. What I found out is you need to concentrate more on these things. You understand?
Yeah.
In these things, how to factorize, and because not every time you would be having access to the calculator, it can be a calculator not assumed.
Yeah.
Okay. Are you typing something? I am getting some noise, something like that.
No, I'm not typing anything.
I don't know why then tuck tuck tuck. There is some sound of tuck 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 type of a thing.
Oh, okay, no.
Are you also getting that or no?
No, I'm not, no.
Okay, I don't know why I am here. Okay, so this was something which we did. We do some questions from exercise 6b. Do you have a book
Yes.
or okay, let's do first question and I put a question here and you try to do it. So I take a question and let's do a simple question first. Let's say y is equal to 4e 0.5x. Can you let me know what is dy upon dx? You will have to solve it is without calculator assume.
dy upon dx. It is 2e to the power of 0.5x.
Very nice. It is same because you took just 4. The reason was yeah, that's correct. Okay, let's do something like I am taking another question, which is question 23 of the book. It says y is equal to ex cube. So what would be dy upon dx?
So dy upon dx would be 3x squared times e to the power of x cubed.
Yeah, 3x squared into e cube of x cube. Very nice. That's good. And we do something like a question number 26 now. It is y is equal to ex times. Yeah, kindly solve this.
Yeah,
So which rule you will apply?
the product rule.
Yeah, product rule.
So it would be e to the power of x times by 1 over square root x.
So this would be e to the power of x times.
1 over square root x
Yeah,
plus square root x times e to the power of x.
okay, square root x times. So yeah, that's correct.
Yeah.
Okay, good. So this was question number 26. Let's do one or more. Let's do question number 27 just for some more practice. So question number 27 is y is equal to e raised to the power x divided by 2x. I
So,
think the question which we did needs, sorry, I think before we do this question, we have to attempt the last question. I have to do it with you, this one.
okay.
I take us different. So if you see dy upon dx becomes e to the power of x into x. So if we, what is derivative of under root x?
Derivative
It is actually,
is 1 over. Oh, yeah, x to the power half.
so what is the derivative
Oh,
of
yeah.
this? So there has to be
It's.
1 over 2 which was
Yeah,
missed, I suppose.
whoops.
Yeah,
Yeah,
what
yeah,
is
yeah.
dy upon dx?
Yeah,
So
so
what is
it's
d
1.
of under root x? What is this thing then?
Yeah, so it's 1 over 2 square root x. Yeah, I messed up.
Yeah, you missed that. So it becomes 1 over 2 times. So it is here 1 over 2, yeah?
Yeah,
And then you have something like, okay. So if we see, so this dy upon dx becomes ex times 1 over 2 under root x, yeah? Or
yeah,
plus, so we have under root x into ex here also, because now, so it becomes under root x into ex. Do you understand that or no?
yeah, I do.
Okay, and if we try to solve this, and so it becomes e raised to the power of x common, yeah?
Yeah,
And then it becomes, okay, let me, because just, so it becomes e over x into under root of 2x plus e over x into, which we have already written it. So I just wrote it once more. And then we
Yeah.
take e raised to the power of x common. And let me write it in a horizontal way instead of a slanting way. Let me just erase it for a minute because I am writing like this. So this becomes, so we take e raised to the power of x common. So it becomes 1 over 2 under root x, yeah, plus under root of x. Yeah.
Yeah.
Can you somehow solve that expression inside the bracket?
Solve the expression inside the bracket.
Yeah.
Um.
Can you take,
hmm,
can you solve that?
I think so.
Yeah.
I think I've forgotten though.
Sorry.
Um. I'm sorry. I've forgotten. I've
You
forgotten how
forgot.
to. Yeah.
Uh, Actually, this is something which is very basic, and therefore I just wanted to revise it with you. If you see, let me take another color, and instead of doing this, I would do here. If you have an expression like this, uh, let me move it a little higher. Yeah. Let's see, we have something like A over B plus C. So can you say how to add them? It's addition of fraction actually. We have one thing in fraction and the other is a whole number. C is a whole number because it does not have a denominator. But once there is no denominator, what is the number which we assume is there?
Is it A over B plus B times C over B?
Sorry, say again.
So is it so yeah, so A over B
Yeah.
plus B times C over B?
Okay. A over B plus C times B upon B. Yeah.
Yeah.
And then,
And then you add the
sorry. Yeah.
no worries. And now they have the same denominator, now you can just add.
So we take B and we
Yeah.
A plus CB here. Good. So you have to do the same there. Uh, So except that now we have something in a little tricky notations like under root or something, but it's almost the same thing.
Okay,
So
yeah.
just try that.
Okay. So uh would it be something like so it needs to be two square root x times square root x.
Yeah. And what is, yeah. And if you multiply 2 square root x with square root x, so what is the answer?
Uh is it is it fourth root of 2 times fourth root of x over 2 to the power of x? 2 square root x?
Let's see that. I just take this thing out, what we try to do it. So I take another color instead of green and red, I take blue color. So what we are trying to do is we are trying to do 2 times under root x times under root x. Yeah.
Yeah.
Do you remember something like index rule? It says if it is index rule. So let me write it
Yeah.
here.
I would have to add. Oh, I would have to add. Yeah.
Index
Okay.
rule says a raised to the power of x times a raised to the power of y is equal to a raised to the power of x plus y. You know that?
Yeah.
So what is, can I write in another form? What is under root x if I have to write it in a form of power?
2x.
No, what is under
Hmm?
root?
Under root is x to the power of a half.
X to the power of half times x to the power of half. Yeah.
So
And now
equals,
we use this rule. Yeah. Which rule?
yeah,
We use this
no,
rule here. So it becomes what this thing become? 2x
2x.
half plus half. So this becomes 2x. Yeah.
Yeah.
You understand that?
Yeah.
So can you help me now to write this in x, what is here in the bracket in a sim?
Yeah. So now it's 1 plus 2x over 2 square root x.
Good. It becomes 1 plus 2x over 2 under root of x. Good. Yeah, have you understood this?
Yeah.
I deliberately brought you here because I think using the calculator sometimes one forgets to do basic algebra or basic things. Yeah. So dy upon dx, which was our question number 26. So the question number 26 becomes ex1 or yeah. So this is the answer. Good.
Yeah.
Okay. Let's do something more tricky maybe, or because I think it's very necessary that you do these questions, because in the 8R it's not only the differentiation or anti-differentiation, they are based upon your previous learning of the year, maybe 10, 11, or even earlier.
Yeah.
Okay, let's do one question and then we would do move to 34. Because I think we should, these things which we are doing up till now in 8R question, normally these are not the question. We have something like expressions which you have to understand. Okay, which one you would like to do from 31, 32, and 33? Anyone?
Um, I think 31.
Okay. The question number 31 says, find the gradient. Find the gradient of y is equal to e raised to the power 2x plus x square. I recommend that you should do all the questions of the exercise, because that would give you the one thing which I found, you need some improvement with this factorization and the solution of that, and that can only be learned by doing more practice.
Yeah.
So I would recommend that, taking the advantage of this lockdown, you start doing as many questions of the exercise as possible. Okay,
Yeah.
so how to do this question? Gradient means, what means the gradient?
Um, Gradient is the y equals mx plus c.
No, gradient, that was y that is the equation of a straight line, and we do
Oh,
not
okay.
have a, this equation is not of a straight line. What is the gradient? If you are given a function and you want to see what is the gradient, so how you find that?
You find the derivative.
Yeah, the gradient is in fact the derivative. So gradient of a function is its derivative. So you are trying to find dy upon dx because gradient. So this is the gradient.
Yeah.
Yeah, gradient is equal. So find what is dy upon dx in this case.
Yeah.
Yeah. What is so can you differentiate and let me know what is the dy upon dx of this expression?
Yeah. So dy upon dx is 2 times e to the power of 2x
Good,
plus 2x.
good. And then we have to find the gradient at. We have been given the points. What are the points? 1, comma, e square plus 1. So we have to find this gradient at this.
Yeah.
So we are given this, sorry, it is 31. Yeah, we are given this. So what we have to find, put it there.
So, okay. So substitute 1 in.
Yeah,
That gives us, that would be
yeah,
2e to the power of 2 plus 2.
good. This is our gradient and we can take 2 common. So it becomes e square plus 1. So far so good?
Yeah.
Okay, good. We would do some question which is interesting to do now because the function we are seeing it's exponential. So we would do 34 question. Question number
34.
34.
Okay.
And perhaps it would be the last question we will do today. So kindly read the question and then can you read the question please a little louder?
Oh, allowed it. Oh, yeah, sorry. So if $100 is invested at 8% per annum, compounded continuously, the account grows to $100 times e to the power of 0.08t after t years.
Yeah, just a minute. So this was something which we covered in the last session. We said if it is, and I stressed upon that if it is compounded continuously, again, compounded continuously,
Yeah.
not compounded annually or bi-monthly, monthly or 6 monthly or per day. No. If it is compounded continuously, only then you can write it in the form of P or the amount is equal to, if you remember the last lecture, it was A naught e raised to the power of kt. The k would be positive if it is progressing, and if it is something like a decay, the k would be negative. Do you remember that from the last session?
Yes.
Okay, so it's the same thing, but I had stressed that remember it has to be in a compounded continuously. Perhaps you
Yeah.
remember that. Yeah?
Yeah.
Okay, so it's the same thing now. And here, uh, what is k? The const.
K is 0.08.
Yeah, and is it positive? So it does it means it is increasing or decaying? For example,
It's positive,
so positive means it is
increasing.
good. Last time we had some question like bacteria being killed or something like that. So we would do
Yeah.
this. Yeah, yeah. Now read the next part.
So what is the instantaneous rate of growth in dollars per year corrected 2 decimal places when t equals 1 and t equals 10, t equals 20, and t equals 40?
Can you quickly find this and just let me know what is the answer of part A
Yep.
and part B, part C, and part D. Yeah. Let me know the answers quickly.
Of
We
course.
have an equation which is actually, so I just write the question. Equation has A is equal to 100 times 0.018. Yeah.
Um. So what is it?
So what is the answer of A part?
So A is. Give me a second. Sorry. A is. A is 8.67.
Yeah, $8.67.
Yeah.
And it is what unit?
Uh.
$8.67. So it is the rate of increase of the amount $8.67 per year.
Okay. Yeah.
Yeah, you understand this?
Yeah.
And what is the answer of B?
So B is. B is 17.880.
So
Yeah.
17.80
Eight. Yeah.
dollars per year.
Yeah.
What is C?
C is $39.62 per year.
$39.62 per year.
Yeah.
What is D?
And D is $196.26.
196.26
26.
per year. Look at these things. Look at these data which is you have just dictated me. And
Yeah.
can you comment upon this thing?
So
What
the
this data says, this what you have found actually, what is this thing? This was
dollars per year
the
increase.
amount growth rate, yeah, the
Yeah.
rate of growth, instantaneous. So what you see from this data, do you see some pattern?
Yeah. So so the larger the number, the more it grows. Is that
Larger the number, or you say, what is this number actually? Which you say larger the number. What is this value?
larger the T,
Yeah, what is this T in this question?
the more years.
The more years. So it means the growth rate is increasing, like this pandemic. So if you
Yeah.
see, the first year it was 8.67. So this is something like this. So this 8.67 is not the value. What is this thing? It is the gradient,
Yeah.
how steep this thing is going. So it means it is like this. So if you have a straight line, y is equal to mxc, and what is a gradient there in this y is equal to mx plus c mean? In the straight line equation, what is a gradient? What thing represent the gradient if it is y is equal to mx plus c?
Um. M.
Yeah, m. And it is constant. It's not changing because
Yeah.
the slope is constant. You understand that?
Yeah.
But in case of this exponential, the gradient is changing, and therefore the people, therefore at the moment what you see in the whole world, the people are locked down. What they are
Yeah.
trying to do?
Lower the exponential rate.
Exponential rate. Very nice. Keep this exponential rate or this gradient low, because if you
Yeah.
let the people interact with each other, this curve would grow. This pandemic or the sickening of the people become sick, the rate would grow exponentially, and healthcare system would not be able to handle it. Do you understand this today
Yeah.
with this mathematic background of exponential? So we do not want that we go out of it because so in that case, it's the number of the patients which will become this curve. Let me highlight it instead of, but I think you understood. If you have
Yeah.
some question, kindly let me know. So we are saying this would be the number of patient, and therefore they are trying to, perhaps you have heard in the news or something, they want to keep this curve down.
Yeah.
Hopefully today you understood more what these news are saying. Yeah.
Yeah.
So we have 5 minutes. I would ask you to do question number 35 yourself. But before I ask you, can you read it? And then I have one question to ask from this question to you. Can you read
Sure.
this question a little loud for me, please?
Yeah. So question 35.
Mm,
So damage to a poorly maintained grain store causes the marketable weight of grain in the store to fall from its initial amount of A of 0 tons to an amount of A of T. T weeks later, according to the rule, A of T is equal to 100 times e to the power of negative 0.1 T tons.
just a minute. Why you see here it is minus? Can you comment
Because
upon that?
it's decaying.
It means, yeah, so it's not increasing, it's decaying. So that the difference you. Can you just, I think you can answer the first part even without doing anything. What is A naught?
A 100?
Yeah, 100, because A naught means T is 0, and if you put T is equal to 0, so it becomes E raised to the power of 0. And
Yeah.
any number raised to the power 0 is
1.
1, so it becomes 100. Very nice. So this is something which we saw. Um, what is the marketable rate of weight of grain in store when T is equal to 5? Can you just, instead of solving it, just tell me how to find that? We,
Um, to find that, you would just substitute 5 in for T
yeah,
in the A of T.
yeah.
So that would give you, give me 1 second. So it would give you around about 60.65 tons. Oh, sorry, no, to the nearest ton. So 61 tons.
How you did that? This is a point which is to be taken care. What is this AT given? A stored false initial to an amount 80. So yeah, so this is the marketable. So it becomes how much is? Can you just said?
61 tons.
Yeah, okay, that's good. So we finish our lecture this session. Kindly do as many questions from the exercise as you could do because you need practice. I just
Yeah.
go through very quickly what we have learned today, just revising the lecture. So we did the exercise 6B, exercise 6B of the Sadler book. So this is
Yeah.
exercise controls, yeah. Exercise, exercise 6B of Sadler. Okay, so this is the exercise 6B of Sadler, where
Yeah.
we found how to do the derivative of Ex. This is the formula which we saw, and I just put it inside box. So this was our formula, which and maybe we can even highlight it. Yeah. So this is the first thing which we learned. Then we learned if y is equal to ex, then its derivative is remains the same. That is in fact a corollary or a consequence of our main formula. Then we did some questions where we've applied the things which we learned earlier, applying product rule and the division rule. And then we also did some of the questions which are mathematical expression, finding the gradient and finding the decay rate or growth rate.